Alright, so this lesson is going to be kind of an extension of what we did yesterday with classifying triangles. We're going to talk about some of the specific angle relations that happen inside and outside of a triangle. So this is angle relations in triangles. And almost all of it stems from the fact that you know one specific thing about triangles. So again, we're going to be drawing a lot of triangles for the next several months. So I'm going to get used to drawing triangles. So if we have a triangle here, it's just a random triangle, nothing specific about it. We have an angle A, angle B, and angle C. I'm pretty sure that most of you already can tell me what the measure of angle A plus the measure of angle B plus the measure of angle C has to equal. What I'm asking you is basically, what do all the angles in a triangle add up to? Well, I think you already know that it's 180 degrees. But what you may not know is, you may not really get that. You might just, yeah, I heard that before, so that's the way we do it. But I'm going to try to show you real quick. Hopefully this won't take much of our time up. I'm going to use a little tool on here, and I'm going to trace this angle that I made. This isn't going to be anything super high tech. But if I highlight all these angles here, and again, I'm not doing a super accurate job, but I can take them off of here. So I can take angle A, I can take angle C, and I can take angle B, spin it around where it's facing the right way, and it'll fit right in there. So I've taken these three angles, I can put them all together, and you can see that they add up. If I take this angle 1, 2, 3, well, they add up to 180 degrees. They make a straight angle. So that's kind of a way for you to visualize how this all works. So all the angles in a triangle add up to 180 degrees. And this is kind of an important thing, and you're going to use it a lot in your proofs. This is called a triangle sum theorem. And we're not going to prove it here today. We might do it in class, or might do it as one of your homework assignments. But this is called the triangle sum theorem, and it just says exactly what you think. The sum of a triangle's angles is 180 degrees. And because of that, there's a lot of interesting things that you can just, you know, they might seem like common sense to you here in a minute when we get going, but we're still going to write them down, and we're still going to make note of them because they are important. So I'm going to draw a right triangle, and yeah, I got my right triangle, so it'll be right triangle X, Y, Z. And I'm going to separate all this with a nice little line so it doesn't get confusing. Alright, so if I look at this triangle, what do all the angles add up to? 180 degrees, right? Well, I know this one already, angle X. I know that the measurement of angle X equals 90 degrees. So that would imply that the measure of angle Y plus the measure of angle Z would have to equal what? Well, it's also 90 degrees, right? Because 90 plus 90 gives me the 180 degrees that I need all inside here. Okay, so just like this one added up to 180 degrees, so does this one. So this is something you can use in your proofs, and a thing that you need to know is that the acute angles of a right triangle, are complementary. This should make sense, right? If I take this angle, angle Z and angle Y, add them together, they got to equal 90. So we're going to keep going. We've got several of these that we're going to write down, but these are all, you might think they're common sense, but this little bit right here, acute angles of a right triangle are complementary. That's a reason in a proof. So see. The next one we're going to do is we're going to draw an equiangular triangle. Equiangular triangle. So I'm going to indicate that all the angles here are the same. They're all congruent, so this will be triangle A, B, C. Now, I know that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees, right? But I also know that the measure of angle A equals the measure of angle B and equals the measure of angle C. So that means I could substitute any one of these in for the other one, right? And instead of substituting, I'm just going to call angle A, I'm going to change it to be X. So I don't know what it is, but I know that it's X. Well, if angle B is equal to angle A, then angle B is also X, right? And if angle C is equal to both of them, angle C could also be X. So what that leaves us with is that X plus X plus X equals 180. Well, 3x equals 180. I divide both sides by 3. I get that x equals 60. So what does that mean? I go back here, this is 60, this is 60, this is 60. Well, what does that have to do with anything? Well, it tells me that the angles, all the angles in an equiangular triangle or equilateral triangle have to be 60 degrees, right? So I could say that each angle of an equiangular triangle measures 60 degrees. Okay, so this could be something we say in a proof. More than likely, it's just going to be something you use in a problem, but you still need to know it. We're going to do something I think is kind of common sense. I'm getting tired of these red triangles, so we're going to draw a little different color one. So here, let's mess this thing up a little bit. So here's one triangle, and then I'm going to take and make another one exactly like it, but I'm going to twist it around a little bit, make it a little different. So I have these two triangles, and you saw me make them, so there's no confusion about whether or not they're identical or they're congruent. So this will be A, B, C, and if I match this up back how it was, this will be D, E, F, because this A and D were in the same spot. They're corresponding B and E and C and F. So I have these two triangles here, and if I told you that A and D were congruent, and then I told you that B and E were congruent, what do you think is going to have to be true about angle C and angle F? Okay, hopefully you're saying that they would have to be congruent, but let's just look and make sure. We know that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180, right? And we also know that the measure of angle D plus the measure of angle E plus the measure of angle F has to equal 180 also, doesn't it? But we know that these two angles are congruent to each other because they're marked congruent, so I could just swap them in and out for each other. We know that these two angles are congruent for each other, so I could just swap them in and out for each other. And I know that 180 is the same thing as 180. So the only thing in these two equations that could be different would be these two things. So I'm going to rewrite this a little bit differently. I'm going to write that the measure of angle A plus the measure of angle B plus the measure of angle C equals the measure of angle D plus the measure of angle E plus the measure of angle F. And I had to write kind of small there to fit it on my screen. But so I'm going to subtract the measure of angle A from both sides. Now you might think, well, you can't do D minus A, but I can because I know they're congruent. So those would just go away. And if I subtract the measure of angle B, All right, I know that E and D are congruent, or E and B are congruent, so those go away. And all I'm left with is that the measure of angle C equals the measure of angle F. So that tells me that they're congruent. And this idea is called the third angles theorem. Okay? It's nothing really exciting, but it is a reason in a proof, and it's something that you're going to have to know and be able to use on your test. All it says that basically is if two angles of two triangles are congruent, then the third angles are congruent. And that's why it's called the third angles theorem, because it tells you the third angles are congruent. So we just got one more to do, then we're going to be done. And this is definitely, I think, the coolest one and the most usable one. So I'm going to make a little triangle here. This is the one that we can do the most, I guess, expand on the most for our purposes. So I'm going to draw a triangle here, and I'm also going to extend the bottom of it here. So I've got this thing, this little shape. Looks like a, I don't know, looks like a triangle with a line sticking out of it, I guess. But I'm going to label these angles here. I'm going to have angle 1, 2, 3, and 4. Now, a vocabulary word that you really need to know is that angle 1 and angle 2 are called remote interior angles. And the reason they're called remote interior angles is because they are on the opposite side of the triangle or away from this exterior angle. This angle right here, angle 3, is just called an interior angle. Okay, now if we drew the line out of this side, then this would be the interior angle, and these would be the remote interior. Or if we drew it over here, this would be the interior, and these would be the remote exterior, or remote interior. But either way, the big idea here is that the remote interior angles and the exterior angle have a relationship, and we're going to look at that right now. I know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180, right? Well, I also know the measure of angle 3 plus the measure of angle 4 equals 180, right? So I'm going to come over and I'm going to rewrite this. I'm going to get rid of the 180s, and I'm just going to write that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals the measure of angle 3 plus the measure of angle 4. I'm just substituting here. Instead of writing 180, I'm writing measure of angle 3 plus measure of angle 4. Well, I'll start moving some stuff around. I'm going to subtract the measure of angle 3 from both sides. Those go away. And I'm left with the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. Now once I have this, this is one of my remote interior angles plus the other remote interior angle, and they always equal the exterior angle. And what this is called is the exterior angle theorem. And this is a big reason in a proof, and we're going to do lots of problems with this kind of stuff. And the exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of its remote interior angles. Now that may not be word for word, it's not a textbook theorem definition thing, but that's basically what it says. It says that the measure of this angle out here is equal to the measure of the two remote interior angles. And a real easy way to visualize that, I'm just going to duplicate all my stuff here and make us a little problem real quick, and then we'll be done. But it's important that you can do this, because when we come into class tomorrow, you're just going to have to be ready to go on this. So let's say that this angle is 125 degrees and this angle is 40 degrees. Okay, the question is going to be, and we'll go ahead and do A, B, C. And I should probably separate this so you don't think this is part of the theorem. But the question here is, what is the measure of angle B? Well, it's a very easy problem. There's a lot of ways to do it. If we use the exterior angles theorem, we know that 125, the exterior angle, equals angle A, which is 40 degrees, plus X, angle B. We subtract 40, and we get that X equals 85 degrees. Another way, though, that you could have thought your way through that is to look right here. This 125 degrees, and let's say that this is Y. Well, 125 plus Y has to equal 180, because this is a linear pair, and linear pairs are supplementary. So we'll subtract 125, and we'll get Y equals something, 55. So that means that this angle right here is 55. Well, 55 plus 40 is 95. So that means these two add up to 95, and I know the whole thing has to be 180. 180 minus 95 is 85. So either way I do it, whether I use the exterior angles theorem, which is this way, or if I just kind of common sense my way through it, is this way. I'm still going to get 85 no matter what I do. So you really want to make sure you know all of these. Make sure you know the theorems, make sure you know what they mean. They're too easy for you to just blow these off and not memorize them. So that's it for today, and we'll pick it up tomorrow.